My enzyme was the strings in my racket. One property of an enzyme is that they are proteins, resulting in that my strings are proteins. Enzymes are catalysts that speed up and allow biochemical reactions to occur. So here is an example without the enzyme. The reaction of the ball moving is very slow compared to when there is an enzyme present. The substrate, which is the molecule being acted upon by the enzyme, is the tennis ball. Enzymes are specific to a particular reaction. They will act only on one type of substrate. Here you can see that the enzyme or the strings can't do the reaction with a different type of substrate or the basketball. The enzyme and substrate physically meet at a location called the active site. Here you can see that the substrate, the ball, hits the middle of the enzyme or the strings. The active site is the middle of the strings. The enzyme-substrate complex, or where the enzyme and substrate are connected, is where the ball or the substrate hits the enzyme or the strings in the middle. When the reaction is complete, the enzyme and substrate separate. The ball and the strings are separated. After the reaction occurs, the substrate changes and is called the product. But after the reaction occurs, the enzyme remains the same and can support the same specific reaction again and again. The strings can hit the tennis ball again and again. The enzyme can be denatured or go through conformational change. For the string, getting denatured occurs when someone breaks the racket, causing the strings to not obtain shape. Here, a couple of strings are denatured and one isn't. Optimal range is the range where the enzyme works the best. One optimal range for the strings is the tension in them. Here you can see me feeling if the tension in the strings are near 50 to 55 pounds, which is optimal range. Another optimal range for the strings is the temperature. If the temperature is too hot or too cold, around 100 degrees Fahrenheit or 30 degrees Fahrenheit, the tension of the strings is altered to a bad tension. Some enzymes require coenzymes or cofactors for catalysis to take place. The coenzyme of the strings is the racket frame. Without the racket frame, the reaction couldn't take place. Competitive inhibitors can bind to the active site and block substrates from attaching and hindering enzyme activity. For strings, water can hinder how the strings hit the ball. Non-competitive inhibitors can bind somewhere other than the active site and cause the enzyme to change shape, preventing the substrate from binding properly. Here the bag is covering the whole active site of the strings and the racket frame and cannot perform the reaction.